XNU is the computer operating system kernel developed at Apple Incorporated since December 1996 for use in the Mac OS X operating system and released as free and open-source software as part of the Darwin operating system. XNU is an acronym for X is Not Unix. Originally developed by Next for the NeXTSTEP operating system, XNU was a hybrid kernel combining version 2.5 of the Mach kernel developed at Carnegie Mellon University with components from 4.3 Bahamian and an Objective-C API for writing drivers called Iokit. After Apple acquired Next, the Mach component was upgraded to 3.0. The BSD components were upgraded with code from the FreeBSD project and the driver kit was replaced with a C++ API for writing drivers called Iokit. Kernel Design, XNU is a hybrid kernel, containing features of both monolithic kernels and microkernels, attempting to make the best use of both technologies, such as the message passing capability of microkernels enabling greater modularity and larger portions of the OS to benefit from protected memory, as well as retaining the speed of monolithic kernels for certain critical tasks. Currently, XNU runs on ARM, IA32, and x86-64 processors, both single-processor and SMP models. PowerPC support is removed as of version 10. Mach equals, the basis of the XNU kernel, Mach, is a simple microkernel. As such, it is able to run the core of an operating system as separated processes, which allows a great flexibility, but this often reduces performance because of time-consuming kernel user mode context switches and overhead stemming from mapping or copying messages between the address spaces of the microkernel and that of the service daemons. With Mac OS X, the designers have attempted to streamline certain tasks and thus BSD functionality was built into the core with Mach. The result is a combination of Mach and a classical BSD kernel, with some advantages and disadvantages of both. BSD equals, the Berkeley software distribution portion of the kernel provides the POSIX API, the Unix process model at top Mach tasks, basic security policies, user and group IDs, permissions, the networking protocols, the virtual file system code, several local file systems such as HFS, the network file system client and server, cryptographic framework, Unix system v inter-process communication, audit subsystem, mandatory access control, and some of the locking primitives. The BSD code present in XNU came from the FreeBSD kernel. Although much of it has been significantly modified, code sharing still occurs between Apple and the FreeBSD project. K32 per 64 equals, XNU and Mac OS X 10.6 Snow Leopard and later comes in two varieties, a 32-bit version called K32 and a 64-bit version called K64. K32 can run 64-bit applications in userland. What's new in Mac OS X 10.6 is the ability to run XNU in 64-bit kernel space. K32 is the default kernel for 10.6 server when used on all machines except newer Mac Pro and SAV models and can run 64-bit applications. K64 has several benefits compared to K32, can manage more than 32 GB RAM, as the memory map would consume a disproportionately large area of the 32-bit kernel space. Cache buffer sizes can be larger than what the 32-bit kernel space allows, potentially increasing I/O performance. Performance is increased when using high-performance networking devices or multiple GPUs, as the kernel can map all of the devices in 64-bit space even if several have very large DMA buffers. Booting while holding down 6 and 4 will force the machine to boot K64 on machines supporting 64-bit kernels. K64 will run 32-bit applications but it will not run 32-bit kernel extensions, so these must be ported to K64 to be able to load. Iokit equals, Iokit is the device driver framework, written in a subset of C++ based on embedded C++. Using its object-oriented design, features common to any class of driver are provided within the framework itself, helping device drivers be written more quickly and using less code. The Iokit is multi-threaded, symmetric multiprocessing safe, and allows for hot pluggable devices and automatic, dynamic device configuration. Many drivers can be written to run from user space, which further enhances the stability of the system. If a user space driver crashes, it will not crash the kernel. However, if a kernel space driver crashes, it will crash the kernel. Examples of kernel space drivers include disk adapter and network adapter drivers, graphics drivers, drivers for USB and FireWire host controllers, and drivers for virtual machine software such as Parallels Desktop for Mac and BMW ARE Fusion. Protecting shared resources. In order to run safely on multiprocessor machines, access to shared resources must be serialized so that threads or processes do not attempt to modify the same resource at the same time. Atomic operations, spin locks, critical sections, mutual exclusions, and serializing tokens are all possible methods that can be used to prevent concurrent access. Like recent versions of Linux and FreeBSD, XNU, as of Mac OS X 10.4 and Darwin 8.0, employs a fine-grained mutex model to achieve higher performance on multiprocessor systems. See also Columbia CIDR. References. External links: Apple Open Source Browser, XNU, unofficial mirror of XNU at GitHub, XNU, the kernel, an overview of the components of XNU, written by Amit Singh in December 2003, inside the Mac OS X kernel. This talk intends to clear up the confusion by presenting details of the Mac OS X kernel.